Hello everyone, welcome to Geeks for Geeks. My name is Nitin Kaplas. Let's talk about today's contest problems. Our first problem is it's payday, right? So let's read the question first. Our question is Geek borrowed money from two people, A and B, right? He borrowed amount X1 from A at an interest rate of R1 and amount X2 from B at the rate of R2, right? As exactly 1 year has passed since he borrowed the money, Geek need to return money back to A and B, right? We have to help Geek find out whom he owes more amount of interest money, right? Which simply means which A or B people, right? Which people we have to give more interest in simple words. So in the first example, we have x1 is 100, right? Which is the borrowed amount at the rate of 5%. And from second per people, which is B, so we borrowed 50 rupees at the rate of 10%. So here the output is equal. Let's do the dry run of this case. Let's suppose, okay, so this is my first example. Let me write here. So the x1 here is 100 at the rate of R1, which is 5, and x2 at rate rupees 50 at the rate of 10%, right? Okay, so it's very simple. If we have to calculate, right? Let me write here first how we can calculate the rate. So here 100 is the amount into 5 by 100, right? Simply the interest is 5 rupees 5, right? In this case 50 is the amount which Geek taken, right, at the rate of 10%. So simply the interest amount is 5. Both are equal, right? Both are equal. In this case we have to return a string as equal, right? Now let's talk about its second example. In second example, 1000 amount at 50%. Let's take this as 50% 1000. x1 is 1000 at the rate of 50%, right? Let me rate 1000 and 200 rupees at 20%. x2 is 200 at rate of 20%. Okay, it's 20. Now simple, 1000 into 50%, 50 upon 100, it's 500. The interest amount is 500 in this case. Here we have 40. So which is higher, first or second? This is higher. In this case, what he said, if first people is greater now, we have to return, we have a interest maximum in the first case, we have to return A, else we have to return B, right? Which people have, we have to return more interest. So in this case we have return A. So how to solve this question? It's very simple. Just multiply this thing x1 into r1. This formula we have to do. So in this formula we are using 100 here, 100 here, right? It's a common, so we are not using here 100. After that we just compare it, right? So let me write here. So here we have to use long, right? Because if you see the constraint part, it's 10 raised to power 9, right? x1 or x2 will be go to 10 raised to power 9, and we are also multiply with r1 r2, right? So it will be out of range. So in this case we are using long. So let me write here A, right? So let me change here to long x1 into long r1. No need of like divide by 100, right? Because it will be cancelled out. x2 into R2, right? So we are done with this. Now we are just want to compare these two things. Let's compare this. If A equals to B, right? In this case, we have to return equal string. Let return equal here. Else, if A is greater than B, here we have to return string A, right? Else, we have to return B. Okay, so this is the simple steps of it. Let's compile and check. Yeah, the compilation is good. Let's submit it. Yeah, as you see all, we are successfully solved the problem. Okay, so let's talk about time complexity. We are just simply like multiplication and comparing. So here complexity is big of 1, right? It's a constant, right? Hope you understand this question. Now let's talk about second question. Our second question is number game, right? Let's read the question first. Our question said, Geek is appearing for a coding contest. The aim of the contest is to score exactly n points. He is given an integer k before the start of the contest, right? For each problem he solved during the contest, he is asked to choose an integer m, any number n, right? And m the power k is added to his score, right? To achieve the n points, right? Here we have to help the geek find the minimum number of problems he solved to achieve exactly n points, right? Minimum number of problems we have to solve, right? So let's see the first example. Here first example is n equal to 12, k equal to 2. The output is 3. Let's understand this. Let's understand this, how we can solve this question and what's the intuition, right? If the value of n is 12 and k is 2, here question said we have to achieve n equal to 12, right? And the value of k is given to us, and we have to create m ki power k, right? With the help of this thing, we have to count how many m's we need, right, to achieve n points. But with the minimum number of m's you have to take, right? Let's take when m equals to 1. When m equals to 1 and its k is 2, I have to take m ki power 2. Let's take 1, again 1. 1 ki power 2, 1 ki power 2 up to 12 times, right? So here I have to solve 12 problems if I take 1. Let's take 2. If I take 2, 2 ki power 2, 2 ki power 2, 2 ki power 2. Its value sum is 12, right? 3 times. We have to solve 3 problems in this case, right? Now, if I take 3 ki power 2, right? Can I take 3 ki power 2 again? No. Why? Because its sum is 18, which is succeed, right? Which is greater than n. Let's take 2 ki power 2, 2 ki power 2, which is 13. Again it succeed. Okay. Let's take 1. Let's take 1. 1 ki power 2, which is 10. Again 1 ki power 2, again 1 ki power 2. So if you calculate here, we have to solve 4 problems 4 times. So if you see this pattern and you have to calculate the minimum problems, you have to solve minimum problem. What the minimum problem you solved? 3 now. Your output is 3 in this case, right? Now let's take another example when n equals to 6 and k equals to 2, right? In this case, let's see. If I take 1 ki power 2, 1 ki power 2, 1 ki power 2 up to 6 times, right? Number of problems I have to solve 6, right? 2 ki power 2 plus 2 ki power 2. I don't have to take like this, right? I have to take 1 ki power 2, 1 ki power 2, which is 6. It means 3 problems, right? So if you see this, can I take 3 ki power 2? No, right? Here its value is 9. So minimum is 3, right? So how to solve this question? That's the simple we have to do. How to solve this question? So here we have to use DP, right? We have to solve first sub problems, and using the sub problems we can able to solve the actual problem, right? So before going into the DP problem, let's make a recursive solution first. Recursive solution, right? Now let's assume first, if your n key value is 0 and k is 2, right? You have to achieve 0 points. How many problems you have to solve? Just think about it. You have to solve 0 problems, right? You have to solve 0 problems in this case. So it's a base case. Let's write here. If n equals to 0, we have to solve 0 problems, and in this case we have to return 0, right? Okay. Now, in previous examples, in previous dry run, right, you just assume this thing. I hope you understand this thing. When n equals to 6 now, you can maximum take 1 ki power 2 if your k is 2. I am assuming k here 2, or 2 ki power 2. You are not able to take 3 ki power 2 because its value is greater than 6, right? If you want to add m ki power 2, m ki power k, in that case your m will be 1, either 2, right? I am not able to take 3, right, here in this case, right? So here I am creating a vector first. Let's create a vector where I am storing my possible elements, right, which help me to achieve n points. So only 1 and 4 when n equals to 6 is there. When n is 12, in that case I can take 1, 2 ki power 2 4, 3 ki power 2 9, right? But let's dry run for this case when n is 6, so you can understand easily, right? So let's write here with new case. When n equals to 6, my k key value is 2. In my vector, possible elements I have to take only 1 and 4, right? Only this case. So let's take this an array, right? Let's make an array. Okay. So you have to achieve n equals to 6 using this values. You can take any value any number of time, right? So just think about it. It's DP problem, right? You are given an array and you have to achieve that endpoints, right? So what I am tell you, this problem is similar to minimum number of coins. If you do this question, it's very easy for you. You have this number of coins and you have to achieve that value with minimum number of these coins, right? I hope you understand this, right? Now how we can solve it? Here, as I said, if n equals to 0, this is my base case. Let me write here again. In this case, my n key value is 6. Let's first solve the sub problems, right? Then we are easy to solve the n equal to 6. Now, this is my array, right, which is 0 and 1. When here I am traversing this, when I equals to 0 in this case, right, this value, can I take this value as my answer, into my answer, when I am just adding the value? Yes, because it's 1 is smaller than 6, right? Here I am assuming I am taking that coin, right? I am just assuming that as a coin. So I am taking that coin one time, and now I want my amount should reduce, which is n minus coin. So n is 6 and coin which I am taking is 1, so it's 5, right? Now let's write here f of 5. Now when I'm at f of 5, my n value is 5 right now. Again I go to this array from starting, I equals to 0, right? In this case, can I take that coin? Yes, because its value is less than n. 1 plus f of n minus 1, right, which is 4 in this case. Okay, now I have to calculate f of 4. Let me go again. Again I am going to same, I equals to 0. I take one coin, right, that's why I am adding 1 here, and the value of n is reduced to n minus coin, right, which is 3. Let's go further, f of 3. Again same steps, I equals to 0, 1 plus f of 2. Let's solve first f of 2, right. In that manner, I go I equals to 0, 1 plus f of 1, and f of 1 I have to calculate. Again the value is greater than or equal to, so that I take 1, f of 0. In that case, when I am reaching f of 0 now, that is the base case. When I want to achieve n points, which is 0 points, here I am returning 0. Let's return 0. So in this case I have 0, right. So when I am taking I equals to 0, I am just taking that element 1, and if I am reaching that value, right, when I equals to 0, if you just manually think, when n equals to 1, how many elements you need and how many times? Only one element you need, one time. So here your value is 1, right. Now when I am at go to I equal to 1 now, when I go to this part, in that case your coin value is greater than what you want to achieve. So here n is smaller than coin, that value, right. I am assuming that value as coin, which is 4. Here I have to continue that part. I don't want to use this, right. Continue. So when your f of 1, for f of 1, your this loop is finished now. What is your minimum number of coins, which is 1? Let's give to the parent node, parent function, right. Now here when I am returning this to the parent, this f of 1 is 1. So your number of coins is 2 right now. I am just assuming in whole loop, right, as a infinite minimum number of coins, right. I am just comparing with the infinite. Here I have 2. When I equal to 1, again 4 is greater than 2, right. Again I go to the continue part, right. So what is my minimum coin I want to achieve? 2 now. Just return to the parent. I am just returning this to the parent. This is 2. Now in this case I have 3 coins. I want 3 coins, or say as 3 problems I have to solve to achieve n equal to 3. Now when I equal to 1, in that case the 4 is again greater than 3. Again we have to continue, just return 3 to the parent. In this case, let me erase this. I hope you understand this. I am just erasing this part. Now when I am at here, I just return 3 to the parent, which is updated with 3. At I equals to 0, minimum number of problems or coins we have to solve is 4, right. When I am checking for I equal to 1, in this case again sub problem is going to 1 plus f of n is 4 right now. The value here is 4, right. In this case I have to calculate for 1 plus f of 0. F of 0 is 0, so I am returning 0, right. So what is the minimum in between 4 and 1? Here I am calculating 4, right. I am just taking, I just want to achieve 4 in this case, and I am taking 4 coins of 1 coin 4 times. So here we have 4. Here the second option is I have to take 1 coin, right, of 4, right. So here my output is 1 in this case. I just only take 4 rupees coin, right, one time. So number of coins is here 1. So just comparing with 4 and 1, which is 1 is the minimum. Just return to the parent, right. Let me erase this. Now we have to calculate for f equal to 5, right? So here I have 1, it means I equal to 0, the minimum number of coins I need 2, right? Now when I go for I equal to 1, in this case the value of, right, n is 5 and coin is 4, right? In this case what I am doing is 1 plus f of n minus coin. What is the value of n? Which is 5 minus 4, which is 1. I already solved for 1. What's the 1? 1. Let me replace here 1, which is 2. So what is the minimum of these two? 2. Just give to the parent. Now here I am returning 2 to the parent. At I equal to 0, I have value 3. When I am calculated at I equal to 1, in this case again 1 plus f of, right, n minus 2, n minus 4, which is 6 minus 4, which is 2. I already calculated for 2, which is 2. Let me replace this, which is 3. So what's the minimum of these two? 3 and 3, which is 3. So in this case, when I am calculating for f of n equal to 6, my output is 3, right? So it's a very basic question. Just calculate for the subpart and calculate the minimum of that subpart. Just return that minimum to the parent function, right? After that we can solve this question easily. Let's do the code here. The first thing is I just make a vector. Let me write the name as coin, right? Coins. I just like replace with the problem coins. Okay. Now I have to write a while loop. Inside this while loop, I have to write par of m, right? M ki par k should be less than equal to n. Until then, we just include that value into the coin vector. Okay. Let me write here par of m ki par k, and each time I have to increment them. So for that, let me initialize the m also here, right? M is equal to 1 initially. Now in this case, let me write min coins as my function. Okay, so where I am passing coins and n, right? So let me write the first recursive solution. So here I am creating a function min coins where I am passing first parameter as my vector, which is coins, and the second is n, right? Now the first thing is a base case. If n equals to 0, I have to return 0 in this case, right? Okay. Now what I said to you, at each n we have to traverse that coins vector, right, from the starting. Let me write here, let me write coin pointing to coins. Okay. Now we have to write the condition when, if coin is greater than the value of n, in that case I have to write continue part. Okay. Now if it's smaller than or equal to, in that case I have to first find the sub problems. Let me write here sub problems. Okay, and just calling the function again. Inside this, right, I have to reduce my n, right? Let me reduce this n, and after that I have to compare. I want the minimum coins from that subpart, right? Let me write here minimum, mini coins. Initially it's infinite, right? Let me write infinite int max. Okay. Right now here 1 plus, right? Because 1 I already taken, right? When I go for the subpart, 1 plus sub problems, if it's less than min coins, right? In that case you have to update your min coins. So in this case min coins is 1 plus sub problems, right? Okay, at the end of this loop you just have to return the minimum coins, right? Okay, let me give the minimum coins. Okay, so at the end of it, I just have to return that, right? Okay, let's check this, it's working fine or not. Yeah, the compilation is good. Let's submit it. Yeah, it's time limit succeed. Why? Because the sub problems what we are solving now, we are again solving that problems in the recursive solution. Now we have to convert this solution into the dynamic programming part. So let me erase this. Using this recursive solution, I solve that into the, I just convert that into the DP problem. Let me write here first DP vector of n plus 1 size. Okay. Now here what you see, all the value of the min coins is int max. Let me write this as it is, int max, right? Now in this base case, n equals to 0, we return 0. Let me write here dp of 0 is always 0, right? Now using this recursive solution, we find until when value is reaching to 1 or 0. We already write 0. So here in tabulation part, we have to write manually. When value is 1 till n, we have to calculate, right? So this is what we are writing here. Now inside this function, we are traversing the coins vector. Let me write this again. Okay, now inside this there is a condition. If coin is greater than n, we have to continue, else we have to find it. So inside this I just write that part which is true, right? So here coin is here n is converted to I part, right? Here I am first finding for I equal to 1, then we are reaching to n, right? So let me write here I in terms of n. Okay. So here I am writing if coin is less than or equal to I. So in that case we can easily calculate. So let me write here dp of I is min of dp of I, right, or 1 plus find the sub part of it. Here I am writing now 1 plus sub problems. So what the sub problem is? Sub problem is calling again that min coin function. So inside this I just reduce the n value to n minus coin. So here I am writing dp of I already solved the min problems here. dp of n is I, just replace with I, and coin is simple coin, right? As simple as that. At the end of it, I just return the min coin. But right now I create a vector dp where my minimum is stored, right? So let's compile and check it's working fine or not. So here a simple error is there, coin was not declared. Okay, so in term of coin, okay, let me write here coin. Okay, let's check now. Okay, so auto of x. Okay, a little bit mistake is here. We have to write coin and here coins. Okay, now it's good. Let's again check. Yeah, it's working. Let's submit and check. Yeah, as you see, all the test cases are passed, right? So now what's the time complexity of this question? If you clearly see, here I am writing a while loop until n is less than or equal to, right? So let's write the recurrence part here. Time complexity is when m is k, right? Here I am writing 1, okay, So let me write here 2, let me write here 3. So in this manner I can use this m, right? How many times? Until is less than this. So if you calculate this part now, its complexity is n ki power, the iteration, maximum iteration we have to take, it's n की power 1 by k, ठीक है, n की power 1 by k. Now if I move to further, here n is, we are already given n, and inside this we are creating a vector of coins, right, or anything you want, ठीक है. So the maximum value inside the vector, right, the size of vector I am assuming here m, right, and the here this loop is maximum go for n, so its complexity is, simple complexity is n 1 by k, right, plus big O of this and big O of n into m, right. This is whole time complexity. If I talk about space, so here I am using extra space n plus 1, so let me write space here I am using big O of n, right. This is whole for this question. Now let's go for the third question. Our third question is rose garden trouble. Let's read the question first. Our question said, Geek, a devoted boyfriend, want to surprise his girlfriend, right, with a beautiful bouquet of roses. Geek has a rose garden with n roses, each of which has a certain value associated with it, right. However, Geek faced a unique challenge in choosing the roses for the bouquet. He must select a consecutive sequence of roses in such a way that the GCD of the value of the chosen roses is less than or equal to a value given, which is k. So here Geek sees your help in finding the number of ways he can create the bouquet while to his GCD constraints. We have to help Geek to find this solution, right. So here the first example is, we are given the size of array which is 4 and the value of k is 3, right. This is the array we are given, 4, 8, 5, 11, right. So here the output is 5, right. So we have to count the subarray, right. Those GCD of that subarray is less than or equal to k, right. If you see here, the first subarray, those GCD is less than k is 4, 8 and 5, right. This is the first, and the second is 4, 8, 5, 11, this whole, right, and the third is 8, 5, 11, and fourth is 5 and 11 and 8 and 5, right. So let's understand this question. The array we are given as 4, 8, 5, 11. Let's write this 4, 8, 5, 11, right. Okay, so just we have to make the subarray and check which subarray GCD is less than or equal to k, right. So the first is 4, its GCD is 4, right. Second one, for example, we have 8, right, its GCD is 8. Third one, which is 5, its GCD is 5, right, because it's a single. Its GCD is also 11. Let's take now as a subarray 4 and 8. If we calculate it GCD now, greatest common divisor, I hope you know how to solve this, right. I am assuming that, right. So if we are calculating for the GCD part of these two, which is 4, right, which is again it's greater than k, so we don't have to choose this one. So another array we have 4, 8, 5. If we calculate for this case, 4 and 8 GCD is 4 and 5 is 4 and 5 GCD is 1. It means its GCD is less. So let's increase my count. Initially my count is 0. Let increase by 1, right. Another we are taken 4, 8, 5, 11. Let's take this. if I am assuming this subarray, its GCD is 4. If I am calculating with 5, it's 1. And if I include 11 into it, its GCD is 1, right? Again, it's less than k. So we increment my count, right? Now, let's move another subarray. This is over, right? This is also over. Let's start with 8 now. 8 and 5. Its GCD is simple 1, right? Because first is the only 1 is the highest common divisor. Let's increase its count to 3. And 8, 5, 11. Its GCD is, it's 1. 1 and 11 is 1. So it's 1. So let's increase the count. Okay. Now let's talk about 8, 5, 11. Now let's 5 and 11. What's the GCD of 5 and 11? Again, common is 1. So it's less than k. Increase my count, which is equal to 5, right? So in this manner, you just have to take any subarray, right? All the subarray you have to take and check the subarray GCD of that subarray is less than k now. If it's less than k, just increment the count. So here my output is 5 in this case, right? So if you solve this question, if you see this question, it's very easy, right? But the constraints make a problem. It's 4, 8, 5, 11. If you see the constraints, let's see the constraint first. Constraint are n will be 10 raised to power 5 and k is 10 raised to power 9 and array I is 10 raised to power 9. So it's very high constraint. Though simple step is we just make a two for loop and make a function for checking the GCD of every subarray, right? So its complexity is very high. So we have to solve this question in n log n time complexity, right? N log n complexity. So how to solve this question? To solve this question, we have to use segment tree here, right? We have to use segment tree. I just suggest you, like, if you are not aware of this topic, please first understand the basics of segment tree, right? How we can make a segment tree in this case. Just first of all, just go and watch how we can solve this, right? So let's solve this. If I just, the first step here in my code, if you see clearly, I just make a class, right, segment tree class, and make a object st, right. Inside this, I am just calling st dot construct segment tree function. Inside that function, I am just passing my array, right, and the size of that array, right. So if you see here, this is my class segment tree. Inside this, I am just make a pointer st, right. So here the function is, right, construct segment tree, right. Inside this segment tree, I passing two arguments. First is array, second is n, which is size of it. So with the help of this function, I am constructing my segment tree of that n elements, right. Let's do it. So if you know that, if I am making the segment tree, I am just assuming the size of my st array will be 4 into n, right. So here I am creating a size of st is 4 into n, right. Inside this, I am again calling a function which is construct st. St means segment tree. Inside that, I am passing it two pointers and one index. So here if you see, array I am passing and index is 0, which is the first pointer, and the last pointer is pointing to n minus 1, right. It's n minus 1, and after that 0. 0 tell me the indexing part. Pass, it started with the index 0, right. Let's move to construct st. So let's make the construct segment tree function. Let me copy paste this and do the dry run part so that you can understand it easily. Okay, let's do the dry run of this case. So my subarray is 4, 8, 511, right? Let's make it. And I am here make a ST, which is segment tree array, right? Let's make a some numberings. Okay. Now I am passing a function f, right? For example, I am passing a function f. Inside this, the first pointer is 0 and last is pointing to 3 and index is 0, right? Let's write here, this is index, right? Now here, what is my SS? SS just simply tell us that segment start. This is my segment start. Let's write here. This is my segment end, right? Now, this is a base case when it's match, right? If it's not match, just find the mid of it. Here I am finding the mid. Mid is 0 plus 3 by 2, which is 1, right? Now I am dividing this into two halves. The first is f of, here I am writing construct part, again calling the construct part. Here my SS is 0 and mid is 1, and here if you know that its indexing is same as heap, right? 2 into S1. Here my S1 is this. Let me write here S1 also. Erase this index and write here S1. If you know the heap part, so my left child is 2 into S1 plus 1, right? The same case, here I have 2 into S1, which is 0 plus 1, which is 1, right? Now, for this case, I am writing here mid plus 1, which is 2, and S3 is 3 and index is 0 plus S1, Si plus 2, which is 2, right? If you see here, this is my SS, right? This is my SE and this is my Si. Again, it's not match, right? It's not match. Again, I have to find the mid. Mid is 0 plus 1 by 2, which is 0. Again, I am calling left part. So, left part is 0 to 0 and here my S1 is 2 into S1 plus 1, which is 3, right? So, here I am reaching the base case where SS and SE is matching, right? So, here I am writing in ST. What's your index? Third index. So, in third index, I am writing array of SS, which is 0, which is 4. Let's write here 4. So, it simply tell me when you are reaching at 0, 0 na, when you are reaching 0, 0, it means that you are here. And if you see here, what will be your GCD of these two? It's simple, one integer is there, so GCD is simply that number, right? So I am storing here 4 as a GCD of it, right? If I am calculating for right side, let's do for right side. So mid plus 1, which is 1, 1, and its index is 2 into Si plus 2, which is 4. So here if you see, you are at this index, right? Your SS and SC both are pointing to same. What will be your GCD of one number? It's same, right? What will be it? It will be 8, right? So let's write here 8. And let me draw another color so you can understand this. Here it's 4, here it's 8, right? And if you see, after storing, I have to pass it to the parent call. Let's pass to the parent, which is 4. Here I am passing 8, right? Now you are at 0, 1, means this subarray. What if you manually check for this subarray, what will be your GCD? 4 and 8, we already calculate, which is 4. Now you have left call, right? You have the answer of right call. Just pass the GCD of these two answers. GCD of 4 and 8, which is 4. Let's write here 4 and make 4. And the index is 1. Let's write here at index 1. It's 4. Right? Okay. Now, your left path is over. Now you have to go to the parent part. Let's move to the parent part. Now I am here. I am solving this left half, right? Now let's solve this right half. Now in the right half, again I am writing SS here, SE here and SI here. So mid is same 2 plus 3 by 2, which is 2. Again I am calling left half, which is 2, 2 and its index is 2 into 2 plus 1, which is 5, right? Now you are at 2, 2, which is 5. It's a single element. So always it's your array is your GCD of single element is that single element. Let's write here single element, which is 5, right? Again, if I am going for right half, right, here I have to write mid plus 1. If you see here, array mid plus 1 and SC is same, which is 3, and here I have to write 2 into SI plus 2. SI is 2, so 2 into 2 plus 2, which is 6, right? Here again we are encountered with the base case. Your SS and SC are same, just store into the SI, right? ST of that index 6, which is same, which is third. It means it's 11, right? Let's make here 11 and let's pass this to the parent 5 and pass this to the parent, which is 11. Now in this case, when you have 2, 3, this 2, 3, what will be the GCD of these 2, 3? So here let me write here. So if I am writing GCD of 5 and 11, what will be it? It will be 1, right? So let me write here 1 and at index 2 I have to write 1. Let me write here 1, right? Now when I am at here, if you clearly see, so my 0, 0 is over, 3 is over, right, and 4 is over, okay. Now my fifth index GCD is 5, let me write here 5, and in that case 6 is also I am writing into it, okay. So right now 2 GCD is 1, okay. For 1 it's already I am writing 4. Now I am just left with 0. Now I am at here, I have to calculate for all the elements, right, which is 4, 8, 5, 11. Now in this case, if you see, this is my, what's the GCD of these? 4. What's the GCD of this? 1. Now what's the GCD of 1 and 4? Let me write here 1 and 4, which is 1 now. Let me write here 1. So GCD of this is 1. If you clearly see, how many element in this is less than or equal to this, right? If you clearly see, it's not my exact answer, right? Here just I am creating a GCD. Now here my first step is over, where I am just creating a segment tree, right? Inside it I just make a sum of the subarrays GCD I already calculated, right? Now it's time to increment the count, right, where I have to store, right? I have to store my answer. So here I am using a 2-pointer approach. The first name is s equal to 0, right? I am also writing in the comments what is doing. Here it's a starting point, right? And e equals to 0 is the ending point of the array. Now what my R store? R is a variable which stores GCD of the range, right, in which we are calculating, and answer is simply increment my count if it's in the valid part, right? Now here it's my stopping case. If s is less than equal to n minus 1 and e is less than equal to n minus 1, means it should not go out of the bound of that array, right? Let's do it first. Let's make it 4, 8, 5, 11. Here my array is 4, 8, 5 and 11, right? So my first pointer, which is S and E, right, both are pointing to 0. Let me write here, S is here, E is here, right. In this case, what I am doing is, I go into the while loop, right. So while condition is satisfied, right, and here I am writing if end pointer is greater than or equal to start pointer. Yes, end is equal to start. Right now it's equal, right. In this case, we are finding the value of GCD of that range, right. Here I am writing R equals to ST dot find range GCD of S I am passing, E I am passing, and array I am passing, right. Let's go into this find range GCD part. Here I am writing the find range GCD, right. Inside it, simple, this is the condition where my pointers are go out of the bound, right. In that case we simply return -1 in that case, right. After that, I pass another function and make another function which is find GCD, right. Here this is my pointer 0 and -1, and this is the size of my array, right. So this is whole array size. Inside that, my SS is here and SC is here. So what is SS? Let me tell you here. Inside this, SS is simply a segment tree start and its segment tree end, right, or say as segment end. Inside this query is it is QS, which is query start, and it's a QE, which is query end, and SI is segment index. This is the same thing, right, which I am doing in the when I construct the segment tree. If I am just calculate this, the first thing is, this is just tell you have the SS and SC pointers. Inside this, you have to calculate your query part, right. Your query is QS and QE. If SS is greater than QE, in that case, or if QS is greater than SC, in that case, it means it's not in your that pointer part. So you simply return 0, right. So in this case, both are pointing to this, and I have to calculate the GCD of this, which means 0 0 ki GCD, right. If you see previously my segment tree, let me show you here. I already calculated in my ST part. In when I am at 0 0 at index 3, I am writing here, right, 4. So its GCD is 4 in this case. So if GCD is 4, R equal to 4, let's go into the main function. Here my R is 4, right. Now here I have to check R is greater than K, right. It's not equal to K or less than K. In that case, I go to the if part. It means you have to increment your E part, right. End pointer, we have to increment it. Let's increment the end part. Now E is pointing to this, and here if you see, you have to calculate the GCD in the range of 0 to 1. If you see in the range of 0 to 1, I am already stored and 0 0 and 0 1, sorry 1 1. So what is it? Just check here. 0 0 is 4 and 1 1 is 8, right. If I calculate for this 0 to 1 range, that GCD store into the index 1. Let's go to the 1 and check what's the GCD of it. It's 4. It's also greater than K, right. It's also greater than K. This part is also greater than K, which is 4, right. So again we have to increment my E part. Let's increment the E. Now E is pointing to this, right. It means that we have to calculate the GCD of this case. So in this case, 0 to 2, you have to calculate for 0 to 2, right. So if you just do the manually part, let's check first in the segment tree. 0 to 2 we calculated. So this is 0 to 0, 1 to 1, 2 to 2, 3 to 3 and 2 to 3. So we are not calculating, right. So that's why we are writing here this range function, find range GCD. this function is again helping us to go into the depth of it and find the GCD of it. Just do the dry run of this case, you already know how to do it. Same steps we have to do what we are doing in the construct BST part, right? So if I just calculate manually part, right, the range of this 0, 4, 8, 5, its GCD is, this GCD is 4, and if I calculate with 4 and 5, its GCD is 1, right, which is less than K. So here my R is 1, right? If I go to this case, R is less than equal to K. Yeah, it's less than equal to K. Now it's high time to increment my answer. Here my answer is plus equal to n minus e. What I am writing here, answer previously it's 0. Now I have to write n minus e. N is 4 minus e. E is 2. So it means that I have two subarrays, those values less than or equal to k. How? But if you see here, you have only 4, 8, 5 subarray now. You are just calculated for this. If you clearly see, its GCD is 1. If I am calculate 1 with 11, right, what's the GCD of it? It's 1 now. It's again small, right? It's again smaller than equal to k. Sorry, it's again smaller than equal to k. Yeah, right. In that case, that's why we are adding 2, right? The pointer is pointing to 2 node, this index, right? It means that this is also valid. After that, how many elements are there? That are also valid. That's why we are increment like that, right? Now, move to this part. If I am adding something into my answer, so I have to increment my SS, right? Let's increment the SS here. Now my SS move to this part, right? This part. Now let me write here output as first part, which is 4, 8, 5, and the second one is 4, 8, 5, 11, right? Now I have to check for this case now, which is 1 to 2. It's calculated or not? If I check for 1 to 2, it's not calculated. Again, in this case, you have to go into this case, which is find range GCD, go into the depth of it, same steps, right? If I am calculating manually for this case, 1 to 2 means 8 and 5. 8 and 5 GCD is 1, right? It's 1. Again, it's less than k, less than equal to k. Here again I am incremented my answer. We go into this case and its answer is n minus, answer is 2 plus n minus e, where what is n here? 4. E is pointing to 2 itself. So here my answer is 4. Currently my answer is 4 here, right? Now again, what's my sub arrays are? First sub array is 8 and 5. Second is, how many elements are in the left? Only one is left. Let's include this now. 8, 5, 11. This is also in my answer. So when I am incremented my answer, go increment your S part also. Now my S is pointing to this, right? Which is f of 2, 2 we have to calculate. 2, 2 I already calculated. If you see here, 2, 2 is already calculated. Its GCD is 5. Let me write here, its GCD is 5, which is greater than k. It's greater than k. In that case, we have to increment my e, right? We have to go into the right side. Let's go into the right side. Now my e is pointing to this, right? S is pointing to this. Now if I calculate for 2, 3 part. So let's check first at the construct part. 2, 3. 2, 3 here if you see already calculated, right? 2, 3 already calculated. What's the value is 1, right? What's my GCD is 1. Let's increment this. So in this case my GCD is 1, which is less than k, right? Increment my answer. Here previous my answer is 4, now n minus e. Let me write here n minus e, n is 4, e is pointing to 3. In that case, my answer is 5, right? Now my answer is 5. So here let me include that subarray also, which is 5 and 11. So in that case, I have to increment my s. Let me increment my s. Now my s is here. Now f of 3, 3, GCD of 3, 3, which is 11. Why? Because it's alone. So again it's greater, right? In that case, I have to increment my e part. Let me increment my e. Now my e is out of bound. That is a stopping case, right? That is a stopping case. So what is my output here? Answer, which is 5, right? So let me again tell you this code. So in the first step, we just create a segment tree, right? We are passing st dot construct segment tree array and n, right? Inside this is the my function, and I am just creating a size of st and passing the construct st to that upper function. Here I am creating the segment tree part, right? After I am creating the segment tree part, just take 2 steps, like 2 pointers. First is 0, second is also 0. In that case, the r is a variable where we are storing the GCD of a range, right? And answer is the initializing answer variable to count the valid subarray, right? Inside this, I am just go into that part, right? S and E, I am just moving that and calculate that subarray GCD. If it's less than or equal to k, I am increment my answer, right? If it's not, just go into the right side, E part, right? After this loop is finished, just return the answer part, right? So just do the dry run of this case, right? After that, you can surely understand the solution of it, right? So now if I talk about its time complexity, so inside this, I am just creating the segment tree. So as you know, creating the segment tree time complexity is theta n, right? Let me write here. Time complexity here is theta n plus, if I go into this case, I am just traversing my array, right, with 2 pointers. Inside that pointer, I am using the find range GCD, right? If you see this case, this tree, right? In this tree, I am just go into the depth of it, right? So inside while loop, if I am just traversing the loop, which is big of n, right, go into the depth of it. Each time I go into the depth of it, maximum, so it's log of n, right? So time complexity is big of n plus big of n log n, right? So I can say that it's big of n log n, right? Now let's check and compile this code. Yeah, the compilation is working fine. Let's submit this. Yeah, as you see, we are successfully solved this problem, right? Hope you understand these questions. Thank you so much.